Chapter 5.6, Inequalities in Two Triangles and Indirect Proof. Okay, so here we have the hinge theorem. If two sides of one triangle are congruent to two sides of another, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So just real quick before I go to the diagram, the included angle, what that generally means is the angle between the congruent sides. All right, so we're going to have two sides congruent on one triangle and then two sides congruent on another triangle. And the included angle will be the angle in between. Let's take a look. All right, now if you see in the diagram, see the two notches here and the two notches here. So this side is congruent to this side. They're both the same length. All right, and notice on the other side, one notch here and one notch here. So this side right here matches this side right here. They are congruent or the same length. Now, as a result, we look at the angle in between these two sides. Since this angle, angle V, is greater than this angle, angle R, okay, we can say the measure of angle V is greater than the measure of angle R. Okay, this is the greater than, less than symbol. Since angle V is greater than angle R, then the side across from it, if we go across from the angle in each case, okay, we have this side here, which is XW or WX, is greater than this side here, which is ST or TS. All right. So if you have the angles between two sides that match from one triangle to the other, you go across, the bigger angle will have the longer side length. Now here we have the converse. It's basically the opposite. If two sides of one triangle are congruent to two sides of another, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So it's basically the opposite of the first case. Let's take a look. All right, once again, we have a pair of congruent sides that match from one triangle to the other. So you want to look at the third side, the sides that are not congruent. We have this side right here, that's AB, and this side right here, that's DE. All right, so AB is greater than DE. Now, if you go across from the longer side, that angle is angle C. That's going to be greater than the angle that's across from the shorter side. All right, so since 12 is greater than 9, angle C is greater than angle F. And that's what they said right here. Measure of angle C greater than measure of angle F. Okay, given that ST is congruent to PR, how does angle PST compare to angle SPR? Let's see. Okay, they marked ST congruent to PR. So let's take a look. And also, we have this side right here that's shared by both triangles. So I can mark that one congruent. All right. And we want to compare this angle right here versus this angle right here. So please look at that and tell me which one is the greater measure. All right, we have two congruent sides matching two congruent sides. So we can look at the third side. Okay, we can see that this side here, PT, is greater than this side here, which is RS. Okay, PT is greater than RS. All right, and as a result, the angle across is going to be greater. So if we go across from the greater side, we have angle S. So the measure of angle S is going to be greater than, and we go across from the lesser side. I shouldn't say angle S. Let me fix that, because there's more than one angle at this vertex here. So you have to use three letters. I'm going to say TSP. Okay, that's this angle right here. So the measure of angle TSP is greater than, and if I go across from the shorter side, that's this one right here, RPS. Okay, the measure of angle RPS. All right, so that's it. Since we had the two sides that match, we looked at the third side length. The longer side had the bigger angle. Example 2, two groups of bikers leave the same camp heading in opposite directions. Each group goes 2 miles and then changes direction and goes 1.2 miles. Group A starts due east and then turns 45 degrees towards north. Group B starts due west and then turns 30 degrees south. Which group is farther from camp? All right, let's see the diagram. All right, so the write-up's a little confusing, but this is where they started. This is where they started, okay? They basically went 2 miles. Group A, they went 2 miles, made a turn, and then went 1.2 miles. And then for Group B, they went 2 miles, made a turn, and went 1.2 miles. All right, so 2 miles right here is going to match 2 miles right here. And the 1.2 miles right here matches the 1.2 miles right here. So we have two pairs of sides that match. Okay, Group A is all the way out here, and Group B is all the way out here. And the distance to the original campsite, I'll highlight it in yellow. This right here is the distance to the campsite, and this right here is the distance for Group A to the campsite. So please tell me which one is farther away, Group B or Group A. All right, it's pretty simple. These two triangles are congruent, so I'm going to look at this angle right here. That's 150. And these two sides, I should have said sides, not, these two sides are congruent to these two sides right here. So I'm looking at the included angle, the one in between, and this included angle right here. Since the 150 is more than 135, that means this line right here is going to be farther. So Group B is farther away from camp than Group A. So the one that's farther away is basically Group B. And that's because 150 is greater than 135. Okay, 150 degrees is greater than 135 degrees. Okay, let's try number 1. PR equals PS. Angle QPR is greater than QPS. Which is longer? All right, let's see. QPR. It said QPR is greater than QPS. All right, we're talking about the angle here. I didn't really write it properly. QPR is greater than QPS. So please tell me which side is longer, SQ or RQ. All right, we have a pair of congruent sides. This side is shared by both triangles, so I can mark that one. And it says QPR, which is this angle right here, is greater than QPS, which is this one right here. Okay, so if I go across from the bigger angle, and again, I'm in between the two congruent sides, in other words, the included angle, that means that RQ is going to be greater than SQ. All right, so RQ is greater than SQ. And that's it. Number 2, same diagram, but RQ is less than SQ. Which angle is larger? Okay, RQ less than SQ. Let's take a look. All right, RQ is less than SQ. See if you can tell me which angle is larger and which is smaller. Okay, once again, we have this side that's shared by both triangles, so I'm going to mark that one. RQ is this one right here, and if we go across from that, we have this angle right here. That is Q. I'll start with R. RPQ. So the measure of angle RPQ. And since RQ is the shorter side, that's going to be the smaller angle. So that's going to be less than. Okay, and we're looking at SQ right here. You go across from SQ. It's this angle right here. So that's going to be SPQ. So RPQ, measure of RPQ, is less than the measure of angle SPQ. All right, this problem or example is from another book. So let's look at problem 3. They want to know what is the range of possible values for x. Let's check out the diagram. All right, so we're given two side lengths. We're given two sides that are congruent. And this side right here is shared by both triangles. So I am going to mark that side congruent to itself. And I'm using 2 notches because they already used one right here. Now, if we look at the angles in between the two sides that are congruent, we have a 60. And in between the two sides that are congruent on this triangle, we have this angle here. And that's 5x minus 20. Now, we don't know the relationship between these two angles until we look at the sides across from the angles. So across from the 60, if we go from the angle to the side, we have a 15, that's side length. And if we go across from this angle to the side, we have a 10. All right, so out of the sides, the 15 is greater than the 10. All right, so from the sides, we have 15 greater than 10. And if we look at the angles, the one across from the 15 is 60. Keep the same sign, inequality sign. And the one across from the 10 right here, the angle is 5x minus 20. Okay. So solving for x, we want to isolate this. The opposite of negative 20 is positive 20. We do that to both sides. 60 plus 20 is 80. Keep this symbol pointing in the same direction. Bring down your 5x. And 20 minus 20 cancels. Now this is x times 5. Solving for x, the opposite is divided by 5. And 80 divided by 5 is 16. The inequality points to the right, and the 5's cancel. We're left with x. Now, is that the final answer? Not quite. Okay, x is less than 16, but it can only go so small or so low. All right, so let's do the other calculation right here. This angle, even though it's less than 60, this angle has to be greater than 0. Okay, so 5x minus 20 is the entire angle, and that has to be greater than 0. Okay, the angle can't be 0 or negative, so this right here is greater than 0. Solving for x, again, the opposite of negative 20 is positive 20 on both. 20 minus 20 cancels. Bring down your 5x. Bring down the inequality symbol pointing to the right, and 0 plus 20 is 20. Here we have x times 5. The opposite is divided by 5. And the 5's cancel. X is greater than 20 divided by 5, which is 4. Now what you want to do is write the overlap. Basically, you want to write them both at the same time. So you put x in the middle. And remember, on a number line, the larger numbers go to the right. So out of 16 and 4, the 16 is on the right. And the 4 is on the left. Okay, x is less than 16. And x is greater than 4. So that right there is your final answer for x. All right, please pause for a moment and try the same thing on this problem here. Find the range of values for x and use the sides across from the angles to determine how large this angle could possibly be. All right, as always, we have two congruent sides matching two congruent sides. You want to look at the angles in between. So we have this angle here, and we have this angle here. Okay, going across from the angle to the side. Across from this angle, the side length is 7. And across from this angle, the side length is 9. So for the sides, of course, 9 is greater than 7. All right, so for the angles, across from the 9, we have this angle, and of course, the red box indicates that it's a 90-degree angle. Keep the inequality symbol, and across from the 7 is this angle here, that is 3x plus 18. All right, we're going to solve it just like before. All right, solving for x, the opposite of plus 18 is minus 18. All right, you do that to both sides. Cancels here. 90 minus 18 is 72. Bring down the inequality and bring down your 3x. By the way, the only time this inequality symbol changes direction is if you divide or multiply by a negative, okay? Otherwise, you keep it the same way. You can subtract or add to both sides and it stays the same. So anyhow, we have x times 3. The opposite is divided by 3. Cancels here. 3 into 7 goes 2 times. Carry the 1. 3 into 12 goes 4 times. Bring down the symbol, and x is less than 24. Now again, that's not the final answer. X can only go so low. So over here, we'll do the other calculation. All right, the angle has to be greater than 0. All right, the angles can't be 0 or negative, so 3x plus 18 is greater than 0. All right, because the angle is greater than 0. So 3x plus 18, the opposite is minus 18. Cancels here. Bring down your 3x. Bring down your inequality pointed to the right, and 0 minus 18 is negative 18. Again, the opposite of times 3 is divided by 3. And x is greater than negative 6. So once again, we need to combine these. For the overlap, you put the x in the middle. The larger numbers are on the right. Think of a number line. When you go to the right, that's more positive, so the larger number is on the right. And the lesser number is on the left. X is less than 24, and x is greater than negative 6. So that right there is your final answer.